We have been discussing about the photochemistry of alkene. We have already looked few examples last time. Today also we'll see few more examples of on photochemistry of cyclic alkenes. So cyclic this is an interesting example of photoisomerization of cycling. This is trimethyl octylene. And we have a system like this. All right, so you have a single bond here, a double bond, and trimethyl. So this is trimethyl octylene, and then this in the presence of light, the proton source is required for this. If you have a proton source, and in the presence of xylene as a solvent, proton source is isopropyl alcohol, CH3 CHO. Right. So this under photolytic condition generates a carbocation, adds to this generation of a carbocation at this carbon, and then there is a possibility of 1,2 shift, 1,2 methyl shift. This, so we end up with a system like this. The positive charge here, and then this of course we have a cis orientation, and then minus H plus going to give a double bond at this position. So this is photoisomerization of double bond under photolytic condition in the presence of xylene as a solvent, isopropyl alcohol. This on further, if we can further continue this, the photolysis under similar condition, proton source, xylene being the solvent, isopropyl alcohol being the CHOH is a proton source, can further add to H plus to this double bond under photo condition. So we get a carbocation like this, a H plus here, a positive charge on this, and this loses minus H plus from the, and then we end up this ends minus H plus to give an exocyclic double bond. So it is a very nice photoisomerization of the this alkene, octylene, trimethyl octylene, where the first generation of a carbocation and then to a more stable methyl shift, and then the double bond. So this is you can see that the cyclic alkene undergo photoisomerization under in the presence of a proton source. The ionic addition of alkene, there is an ionic addition of alkenes have also been reported, but under direct irradiation the yield is not very good, but under sensitized condition, if the sensitizer being 1-cyanonaphthalene, it gives a very good yield of the addition product. So if we have a system like this, 1-phenyl alkene under photolytic condition, H nu protic solvent, and then we have a 1-cyanonaphthalene, and naphthalene as a sensitizer. This in the presence of sensitizer, it undergoes PHOR. The addition to across the double bond takes place, but this is important that the sensitizer leads to this reaction more efficiently and giving rise to more as far as the mechanism is concerned, is an electron transfer reaction. So direct photolysis, as I have mentioned, the yield is not very good. So if we have a plus 1 cyanonaphthalene and then as a sensitizer, then we have a electron transfer reaction. So it gives a radical cation. Alkene is a electron donor, and cyanonaphthalene is an electron acceptor. So we have a radical anion here, a radical cation here, and this radical is the I mean the charge pair, radical cation, radical anion, donor acceptor. This in the presence of alcohol, it adds to the lone pair of oxygen, adds to this positive charge, giving rise to a O R H, a positive charge, and then this further transfer of an electron from one cyanonaphthalene leads to an anion, RH, a positive charge, and then this can undergo proton shift to give a added product, PHHOR. So anionic addition across the alkene has also been reported in the sensitized photolysis, sensitizer being one cyanonaphthalene, giving rise to a very good yield of this addition product. On the other hand, direct photolysis does not give significant amount of adduct, does not give significant amount of so this is it works very well when we have a sensitized reaction. The next topic comes a very important aspect is the singlet oxygen reaction. Singlet oxygen reaction in photochemistry plays an important role because the singlet oxygen is generated under photolytic condition, and then this singlet oxygen adds in 3 different ways, such as in reaction, 4+2, 2+2 addition, and a lot of reactions have been carried out with respect to singlet oxygen. As far as generation is concerned, so the solution of dye, solution so of course we can take any the dye could be methylene blue, or rose bengal. So any of these dyes, solution of the in the presence of oxygen atmosphere under photolytic condition generates singlet oxygen, and then the the singlet oxygen. And this singlet oxygen has a very the reactivity is very interesting as far as the reacts in the singlet oxygen reacts in 3 different ways. Singlet oxygen reacts with organic compounds in 3 different ways. Number 1, in reaction. So if we have a system like this, and then we have of course a singlet oxygen. So it reacts in such a way that we have OH here, and then of course double bond. So this is the product, and this allylic hydroperoxide. Allylic hydroperoxide is formed when there is a allylic hydrogen is available, and then so it acts in this fashion, giving rise to this product. Second second type of reaction, which is which reports with respect to singlet oxygen, is the 4+2 addition reaction. So 4+2 addition reaction. So if we have a diene system like this plus singlet oxygen, can add in a fashion to give a product like this. So this is endoperoxide. Endoperoxide is formed through 4+2 addition of a diene with a singlet oxygen. This is a diene with singlet oxygen. Third type of reaction which is reported with respect to singlet oxygen is the 2+2 addition. Uh, 2+2 addition is also reported, and if you have an alkene plus singlet oxygen, alkene singlet oxygen adds in a 2+2 addition to give dioxetane. Dioxetane is the product. So we can see here singlet oxygen acts in 3 different ways to organic compounds, and because of this large number of reactions have been studied to synthesize interesting products, especially lots of the dienes undergoing 4+2 cycloaddition reaction from this different natural products. So we'll see a few examples of dienes naturally dienes with singlet oxygen. It is not only natural occurring, it is we have all mixed examples of diene. So we have when we have a system so we have if we have a diene like this, of course this is a natural product. Diene, then so H nu, in the presence of oxygen containing dye, generates a singlet oxygen as a reactive species. Generated during irradiation on reaction of the actually here what happens, dye goes to an excited state, dye so if you can write, we can write here the sensitizer on absorption of light goes to a singlet excited state and then to a triplet excited state, then reacts with oxygen, generates singlet oxygen, and but sensitizer goes to ground state. So this is how the sensitizer converts. So here the singlet oxygen is generated and it adds in a 4+2 addition with this diene, adds in a 4+2 addition with this diene, giving rise to a product like this. Double bond, the end of peroxide is formed. And then there is another example is the isobenzofuran reaction with isobenzofuran with singlet oxygen. So here if we have a just let's write like this. Here we have this is benzofuran, you have CCH5 diphenyl isobenzofuran, diphenyl isobenzofuran under so of course the condition is H nu oxygen, the presence of dye generating singlet oxygen adds in a 4+2 addition. So we have a we can add, it adds to like this. So we so the product looks like this. Products 1 2 3 4 5 6 member ring. So you have a right a double bond and then there is an oxygen here. So this oxygen is CCH5 right. So and this under heating conditions it gives a double bond. It gives it opens up with the loss of nascent oxygen. It becomes double bond here, this becomes double bond here, and then this. So there is a cleavage of this formation of double bond. So what we get is a pH. So this forms a double bond, this forms a double bond, and this goes out. So we get a further one more carbonyl, this and then C6H5, C6H5, and then of course we have it. So dibenzoyl benzene is formed from the isobenzofuran, 1,2-dibenzoyl benzene, 1,2. Benzene is formed on reaction with singlet oxygen. So we can see other examples are, if we have a cholesterol derivatives also add reaction with cholesterol derivative, action with steroid. Steroid derivative. Similar steroid derivatives with singlet oxygen. So if you have a system like this, right, you have a two double bonds with the two methyl groups, is an OH here, and then of course and then you have an R. So this acts as a diene, acts as a diene and undergo 4+2 addition with singlet oxygen. So we have a reaction with singlet oxygen giving rise to a product like this, endoperoxide. So you can just write to this. So we have we have a linkage between this and this with one oxygen, another oxygen, and then right, and the double bond here, and of course a methyl group here and the OH here, and the rest of the things remain same. So we can see another interesting example is shown over here. The reaction with a carotenoid derivative, reaction with carotenoid derivative, reaction with carotenoid, reaction of carotenoid derivative, reaction of carotenoid derivative with singlet oxygen. Okay, so we have a starting compound is this one. You have a dimethyl here, there is a CH3, is a double bond OH. So we can see these two double bonds acts as a diene, reacts with singlet oxygen in 4+2 manner, giving rise to a product like this. So we can add oxygen So 1, 2, 3, 4, 5, 6 membered ring is formed. So we have an oxygen, another oxygen, right? We have a methyl group, a 2 methyl group here. Is a shifting of double bond to this. and then we have an OH. Now this product, this is endoperoxide, which is formed after the addition of a singlet oxygen with this diene, naturally occurring carotenoid derivative. This, in the presence of OH, may abstract this double bond like this, and then to generate a just a minute. Abstract this proton, becomes a carbonyl, and then it opens up, and then O minus. So let us write the intermediate which is formed. This is O minus, the methyl group. It's a double bond here, and then we have a this is a double bond. This is right. C double bond O, CHO, double bond O. Okay. Okay. CHO, and then this in the presence of under air oxidation gives carboxylic acid, O minus, COH, and then this cyclizes through the incorporation of this to this, and then what is formed is a cyclized product. So you can see a very interesting cyclized product is formed on reaction of this derivative with singlet oxygen in a 4+2 fashion to give this product. So so there is a loss of, there is an H here, right? There is an H here, right? And then it forms, there is a loss of this group, and then there is a double bond and CHO. This becomes C double bond O and H. H and H, there is here H also. So this is an aldehyde going to carboxylic acid on oxidation. To give this, which the incorporation of this O minus may incorporate to give the cyclized product. So you can see a bicyclic lactone derivative has been formed during this reaction. So that's all for today. Thank you very much.